Alright, I apologize that I had to miss another day here, and as you all well know, my son is not feeling so well, so I apologize having to miss this day. But we are going to finish up here. Our last lesson of the class is going to be a video lesson. And so let's go ahead and quickly review what we did at the end of class yesterday. So we graphed using intercepts. We made a lot of nice connections between solving and graphing. And so when we look at our equation here, y equals x times x minus 4, we connected to the concept of solving equal to 0 to the concept of being your your x-intercept on your graph. So if I split this and say x equals 0, x minus 4 equals 0, so x equals 4, this is all stuff we did yesterday, we put our intercepts on our graph. Now, in order to graph our parabola, we said we wanted 3 points. We wanted to have our 2 zeros and our and our vertex. So in order to find our vertex, we have to find the middle of 0 and 4, and that's at 2. And what that gives us, if we would draw a straight line, what that would give us would be what we would call our axis of symmetry. The axis of symmetry refers to the line the vertex must fall on, because all parabolas are symmetric, so therefore that vertex must fall halfway in between 0 and 4. So then we said we know our vertex falls on the line on the point 2 comma something, or the line where x is 2. So therefore I have to plug 2 into my original equation to find out what y would be when x is 2. So I get 2 times negative 2, which is negative 4. So my vertex is at 2, negative 4. And I draw in my parabola shape, and I'm done with that problem. Our next problem is going to take just a small step here. And we're going to start with an equation in standard form, y equals x squared plus 3x minus 4. And I'd like you to graph this using intercepts as well. And so right now I don't have my nice factored form. However, x squared plus 3x minus 4 is factorable. So you'll have to take that and write it as x plus 4 times x minus 1, because 4 and negative 1 add to 3, and 4 times negative 1 is negative 4. So most of you at this point are able to make your intercepts very quickly. And you can see I can make this 0 if x is negative 4, and if x is 1, I can make my function equals 0. So now, in order to find our vertex, we run into a little bit of a problem here. My axis of symmetry is not going to fall on an exact number, because halfway between negative 4 and 1, well, if I add those together and divide by 2, negative 4 plus 1 is negative 3, divided by 2 is negative 1.5. So therefore, my vertex is going to be at the point negative 1.5 comma something. In order to find what that something is, I have to plug negative 1.5 into either of these two equations. It does not matter because they're the same equation. So I plug negative 1.5 in down here, and I get negative 1.5 plus 4, negative 1.5 minus 1, which is equal to 2.5 times negative 2.5. which gives me negative 6.25. So my vertex is going to be at the point negative 1.5, negative 6.25, and I can draw in my parabola by using factoring and zeros. I can graph this. So you can go ahead and stop this video now and graph your equations on your first worksheet. Your first worksheet is over graphing using intercepts. So graphing in intercept form, you may have to factor like this last example. If you want to pause this video and go ahead and do that worksheet, I'm going to continue on this same video with your second half lesson. So go ahead and pause this and work on that first one. When you get done, come back and watch this second half video. All right, welcome back. Hopefully you were able to get that worksheet done without too much difficulty. Now you notice here we have another quadratic equation in standard form. And we run into a little bit of a problem here trying to do our factoring method or our intercept method because I can't factor x squared plus 6x plus 4. And so now we're going to get into our third type of graphing quadratics. We've done graphing in vertex form, where we have the shifts and the growth pattern. And then we did graphing in intercept form, where you have your your two x-intercepts, and you find your axis of symmetry, and you find your zeros, and you sketch your graph. Well, now we're going to go ahead and do another method. And this other method is a little bit of a shortcut, and we can get to the proof of why this works in Algebra 2. But for right now, I'm just going to give you the shortcut that in any quadratic equation in standard form, remember what that means from our quadratic formula is we have an a value, a b value, and a c value. I can find the vertex using this rule. The x value of my vertex is equal to negative b over 2a. And if you remember, that's a part of the quadratic formula. And so if I want to find where the vertex of this equation will occur, I plug in negative 6 over 2 times 1. Negative b over 2 times a. Because remember, there's a 1 there in front of x squared if there's nothing there. So this is a nice little shortcut that tells me my vertex is going to occur at negative 3 comma something. And I got negative 3 from negative 6 divided by 2 times 1, because 2 times 1 is 2. And negative 6 divided by 2 is negative 3. So now, once I have my x value of my vertex, just like I've been doing with my intercept method, I need to find my y value of my vertex by plugging in a known x value to my equation. Y equals negative 3 squared. And we have to remember, when we're using our calculator, we're going to have to plug that negative 3 in parentheses, or else we're going to have an order of operations issue. So I just plug in negative 3 in place of x to figure out what y would be. Negative 3 squared is 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. Plus 4 is negative 5. So this shortcut allows me to find the x value of my vertex. Once I have my x value, I can plug that back into the equation to find my y value. And now I can graph, because I know my vertex is at negative 3, negative 5. From there, I recognize that it's a quadratic equation because it's x squared, and there's no multiplier in front. We have a 1 in front. I'm going to follow that same growth pattern we talked about 2 days ago, where my graph is going to grow by going up 1 over 1. My second step is up 3 over 1. And I go ahead and sketch my parabola. And if you remember, my next step would be up 5 over 1 if I continued on that growth pattern, because the quadratics grow up 1, up 3, up 5. So let's look at one more example. In this example, you'll notice we have a number in front of x squared. We have a leading coefficient. And that will make a small change here. When we go to draw our graph, that number in front of x squared is going to be a multiplier on our growth pattern, just like it did when you were graphing it in vertex form. That's going to take our growth pattern and double it. So to begin with, I use my rule to find the x value of my vertex. My shortcut says to get x, I take negative b and divide it by 2a. So that's going to be negative 8 divided by 2 times 2, which is negative 8 over 4, which is negative 2. So my vertex is going to occur at the point negative 2 comma something. To figure out what that something is, I plug negative 2 in for x Negative 2 squared is 4, times 2 is 8. 8 times negative 2 is negative 16, plus 6. 8 minus 16 is negative 8, plus 6 is negative 2. So my vertex is going to be at the point negative 2, negative 2. And in order to finish my graph, I need to take my growth pattern and double it. So therefore I would normally go up 1 over 1. I go up 2 over 1. My second step is normally up 3, so I go up 6 over 1 because I've doubled my growth pattern. Alright, so throughout these lessons you've found 3 different ways to graph quadratics in their different form. Hopefully we've made some connections between solving an equation and graphing an equation, and also some different methods we can use to graph equations in different form. Alright, good luck, and we will see you on Monday when we'll review for our test we're going to have on Tuesday.